Here's a video of the FlowQuad program, P9, 9P. You'll never see it start like this. It always starts up with things going, but this shows how you can see different parts of it. Here we'll show the particles first, and they're just flowing around in the field. Here we can show the field and not the particles. Gives you a sense of what the data looks like, and I'll just put these back in and then hide the control panel. You don't really need to do much with that yourself other than you use it. So the main goal of yours is to add a quad tree subdivision basically of the vector field, and we have here we have the first level of the quad tree has divides the space up into 4 quadrants, and then each quadrant has its own color, and the boundary of the space occupied by the node is has a color, and all of the particles inside it have colors that correspond to the node they're currently in. As a particle moves from one node to the other, it changes color. You generate colors that you assign to the node, and just make sure that they're separated enough that you can clearly tell which, as particles move from one to the other, they change. And as you subdivide further, you get now each of the original quadrants have been subdivided into quadrants, and we can go down to another level and to another level. I've got the standard deviation set very strict, so here there's only one place in which the quad tree subdivision did not subdivide. Here so little is happening in terms of the vector flow itself that it didn't pass the standard deviation test, or did pass it so that it doesn't have to be subdivided. As you raise the minimum standard deviation, which is kind of the allowed variation in the region of the quad tree, so that you do not need to subdivide it. We get more and more cases where there are regions that are not subdivided at the last level. So here we can make it pretty loose standards, and lots of the fields are not subdivided even at a fairly high level. And as we raise the standard deviation even higher, we can actually even get all the way up to that's 100% of the minimum standard deviation, which is the standard deviation, the percentage is taken of the whole field, so you have no subdivision when you do that. So usually a good place to have it is somewhere around 80 or whatever. And then of course changing the depth changes that as well. You get different results. This is a 128 squared field. If we open a new version, there are 3 versions of the same field at different resolutions. Well, here's a 64 squared one. So it's a little coarser resolution, and so we get different subdivisions given the different resolutions of the same data set. So here, again, you see the part of the main. Your job is to get these representations of the quad nodes and the colors to match the location that the particle is in at a given moment. I don't know if there's anything else. I mean, you want to be sure that your code works with different scale factors and different particles being used. All of that is all implemented for you, but just to make sure that you haven't broken something, you should be sure to make sure that you could try these things. So I think that's probably a good place to end.